Today's problem is k closest points to origin. Difficulty is medium. This is a common question. Given an integer k and an array of points, where each point is represented as x sub I, y sub I on the xy plane, return the k closest points to the origin, 0, 0. Okay, distance between 2 points, and they give us the distance formula here. Euclidean distance. So what is the distance from point x, x1, y1 to x2, y2? It would be x2 minus x1 squared plus y2 minus y1 squared, and then take the square root of the whole thing. Note you can return the k closest points in any order. Test cases are generated such that there will be a unique answer. All right. There are examples here. It's you sort of, well, you know what? But let's let's do it like this. When you have questions like this, programming questions, there's no need to take the square root here, because we don't care what the actual distance is from a point to the origin. We just care what the distance is relative to other distances. We're trying to find the smallest distances, so we don't care about the square root. So you can see that actually from this one. We want k with the 2 closest points, and so the 2 closest points would be square root of 1, square root of 8. We don't even have to know what these square roots are. You can just take the 1 and the 8. Okay, that is the closest. Again, in this one, obviously the closest one is 0, 0. Okay, so we're not taking the square root. All right. The size of the points array can be between 1 and 10 to the 5th, 100,000 inclusive. K will be between 1 and the size of the array. X1, Y1, the XY coordinates will be between negative 30,000 and 30,000. Expected complexities, time complexity, n log k, and auxiliary space O of k. So that's pointing us towards the use of a priority queue. Topic tags, sorting, not sorting really. I mean, the heap or the priority queue will handle the sorting. It's mathematical. Divide and conquer. I'm not sure about. I'm not sure. I'm not doing anything that I would describe as divide and conquer. But I mean, there's always more than one way to do these things. Some of which I may not have considered. Geometric, yes. Arrays, okay. So let's take a look at this. We can use a priority queue. Let me scoot this over a little bit. We're going to use a max heap. And to use a max heap, we need a custom comparator. I mean, we really need one anyway, because what's going into the queue will be 2 element integer arrays, and there's no default comparator for that. So what we want is, we want a comparator that's going to order the elements descending by first element. Okay. Now it does say that the test cases are guaranteed to produce a unique answer, so we don't really have to be concerned about, well, what if there's a tie, in the distance. So this comparator, comparing integer arrays, 2 inputs, O1, O2, both two element integer arrays, and we're going to compare the first elements of the arrays. We want it to be descending, so we put the second element first, and that is going to order in descending order. All right. Initialize a priority queue. We're calling it max heap using the custom comparator. Initialize an index, I. I from 0 to k. So the first thing we want to do is get k elements in the max heap. Let's see. Now, the constraints say that I will be at least 1. I'm sorry, k. K will be at least 1. It doesn't, well, it doesn't guarantee. Wait a minute, maybe it does. K, okay, yeah, I'm sorry. I take it back. It does say that k will be, well, that still doesn't count. K is, it doesn't say that k will be at least, no, I'm sorry, it does. I'm getting mixed up here. It does say that the array will be at least size k, so we don't have to worry about something like where there are fewer than k elements in the array. Okay, so we're going to put k elements in the array. I added a method here, getDist, to calculate the distance of a point from the origin. And as we discussed, what that is going to be is if you have a point x, y, the distance to the origin is going to be x squared plus y squared, and then take the square root of it. But we already went over the reason that we don't need to take the square root. We're only interested in relative distances. All right, so get the dist, put it into the max heap. And what goes into the max heap is a 2-element array. One is the distance, and we're gonna order the heap by descending order of distance, and I, it's the index, because we need to be able to return the points. The closest points, and the way to be able to do that is to have the index of the points, the index of those points in the original input array. So what we put in the heap is the distance and the index of the point in the original array. All right, once we have k points in there, we're going to put the rest of the points in there. Now, the heap is never going to get any bigger than size k, so that is the O of k auxiliary space here, and that's why we can get an O of n log k time complexity. But we're going to put the rest of the points in there in the same way, except that every time we put a new point in the heap, we're going to remove the point at the top of the heap, and that is going to be the largest distance. So once we get through doing this, we're going to have the k closest points in the heap. All the larger points will have been removed. All right. Define our result list and go through the queue. Create a new list. Let's see, int point max heap poll. Okay, so again, what's on the heap is a 2-element array. First element is distance, second element is an index into the points array. So that's what we're getting here. Take the top element of the heap and get the index into the points array. All right, get the point in the list add the x coordinate, add the y coordinate, and add the list, the nested list, to the result list. Okay, and then return the result list. And that's it. So let's try a compile here, make sure everything is in order. Yeah, okay, that looks fine. And submit. Yeah, okay, so I can't think of anything else to add to this. I hope you liked the video. Give it a like. If you did like it, you can subscribe to the channel, sign up for notifications, and let's see. That's it. We'll see you next time.